ours. Ours mean Timur, Nadhov, and myself. Okay, well, I think it's time, right? Good afternoon, good evening, everyone. It's our great pleasure to welcome Samin Aref, who is a researcher from the Max Planck Institute for demographic research, which is in Rostock, Germany. Samin's academic interests are in scholar migration and mobility. He also does network analysis. He received his PhD in computer science from the University of Auckland, which I believe is in New Zealand. His master's in operation research is from Sharif University of Technology in Tehran, Iran. So without further ado, Samin, welcome, and the floor is yours. Before I sign off, please don't forget to register for the seminar in the chat column of this Zoom session. Sharif. Samin, please go ahead.
Thanks a lot for the introduction. Hello, everyone. It's great to be here. I wish the circumstances could have been different and I could meet you in person, but I'm really excited to see many new faces, and I'm glad that there is interest on this topic. So I'm going to just share my screen. So throughout the presentation, if you have any questions, please feel free to write in the chat. If I miss them, it would be great, Bernardo, if you just signal to me and I will just pause and answer the question.
Yes, I will keep you updated if I see any questions.
Great. Right. So, so can you see my slide?
Yep. Yeah, everything is fine. We can see it and can hear you.
Great. So, yeah, so this is a joint work with a great student and a colleague, Alexander Sobotin from Lomonosov Moscow State University. And I'm really glad to talk to you about this topic of brain drain and brain gain in Russia. I'm going to start with telling you a little bit about bibliometric data. So as many of you already know, bibliometric data is pretty much what we see on the first page of a scientific publication. So for example, on this paper, all this information, names of authors, title of paper, abstract keywords, these are all bibliometric data, and in particular affiliation addresses is what we care most about. So the unit of data is what we call an authorship record. So in this example, there are 8 authors. Each of them has one affiliation address, and that's why this publication essentially gives us 8 units of data, 8 authorship records. So an authorship record is the linkage between a publication and an author affiliation. And the idea behind this work is that each authorship record can be considered as a data point mapping authors to places at a certain publication date. So let's have a quick exercise to see what we can do with that idea. Here are 2 publications authored by Manisha Shah. She has been in Australia according to this publication in 2009, and then in the US according to this 2013 publication. These are 2 publications from Richard Breen in the journal Demography. He has been in the US according to this publication, and then the UK according to this other publication. These are 2 publications from James Raymer. He has been in the UK and then Australia. So if we visualize these movements on a map, we would get something like this. This is a network model where nodes represent countries and the directed edges represent the international mobility or movements of these researchers between different countries. And what we see in here is something that we refer to as brain circulation. So as you can see, each person is moving from a country to another, and they're being replaced by someone else. And this is a part of our theoretical framework for analyzing bibliometric data. All right, so we started working on this topic, and we developed a project series on using bibliometric data for migration. And this project series is nothing but an extension of this exercise that we just had. So we expand this idea to millions of publications from tens of thousands of publication venues in many languages and over several decades. And doing this extension, we would be able to study a wide range of research questions at the intersection of big data and migration. So we have already completed 3 projects. One of them was at an international global level, one about Mexico and one about Russia. And we also have 3 ongoing projects about the UK, Germany, and Canada. So to give you a little bit of background, if we have a situation like this, if person A is in country X and person B is outside of country X, and this happens if A goes out and B comes in, we consider this as brain circulation with a net flow of 0. So this is pretty important because this means that we do not consider nationality of these researchers, or we do not only evaluate movements out of a country, but we consider all the movements from Russia to other countries, from other countries to Russia, and we do not care about nationality or citizenship or place of birth of these people. Partly because we do not have that data in bibliometric databases, and partly because our theoretical framework is not about nationality or citizenship or place of birth. So for this movement of person A from country X to another country, we visualize it like this, with a graph or a network that has, in here, it has 2 nodes or 2 circles and a directed edge. And the direction of this edge is from country X to another country. So if you follow the curvature of the edge in a clockwise manner, you would go from country X to another country. That's how we're representing directionality instead of using an arrow. So another thing we do is to use well-known and simple concepts from demography and migration studies and referring to them in an academic sense. So the country of first publication would be, so the first publication for a researcher would be the academic birth. So in our analysis, we're talking about migration of researchers, or particularly migration of published researchers. And this means that all the movements, all the international movements that people may have before their first publication, we do not see it in our data, and it's not part of our analysis, because what we mean by published researcher is someone that has a publication. So if someone doesn't have a publication yet, they are not a published researcher yet, based on this definition. And then the process of publishing would be the academic life course. The country of first publication would be the country of academic origin, and the country of last publication would be the academic destination. And the number of years from the first publication would be academic age, which represents the level of experience. All right.
Quick question.
So, yeah.
How do you deal with multiple affiliations?
Yeah, we get to that. So what we're doing is we consider the mode country of affiliation for each year. So if a person has maybe 5 publications in a given year, they may have in total, let's say 8 affiliations for that year. We take the mode country among those 8. It could be a single, it could be multiple, but for both situations, we know how to deal with it. We start taking the mode and then looking at this modal country of affiliation. And then we consider a migration when the modal country of affiliation changes such that the previous country disappears from the list. And I'm going to show you an example that clearly illustrates this. All right, I hope I've answered the question. So before jumping to the study on brain drain and brain gain in Russia, I'm going to just briefly mention these 2 previous projects we had. So in this study, we focused on highly mobile researchers or super movers, and we look at the migration patterns of these highly mobile researchers, particularly those who have affiliation addresses from at least 3 countries. So those who have affiliation addresses from at least 3 countries over their academic life course must have had at least 2 international mobility events. And in this paper, we looked at migration. We looked at return migration across different countries, for example, among these super movers. And this other project, which is about internal migration of researchers in Mexico. So this paper is accepted and going to appear in EPJ Data Science, and you may access it using this QR code. So in this study, we analyzed all the internal migration of researchers in Mexico by aggregating the affiliation addresses at the national level. We developed a method for inferring states in Mexico from affiliation addresses, and then by looking at the changes in states, we analyzed and explained patterns of internal migration. All right, so now let's discuss the project on brain drain and brain gain in Russia. So in this project, we had 2 objectives. We wanted to quantify the overall level of international scholarly migration for Russia by using measurements from migration studies such as net migration rate, and we wanted to evaluate the impact of these migration events on the Russian science system.
Hello, there is an interference, so please, whoever pauses it, stop. Okay, right. Thanks very much. Please continue, Samin.
Sure. So yeah, the second objective is evaluating the impact of scholarly migration on different fields of scholarship in the Russian science system. So the source of data is Scopus. So as many of you know, Scopus is the largest database of peer-reviewed scientific literature. It has 77 million documents, and they say that 22% of it is in languages other than English. And in total, they have more than 25,000 publication venues and 5,000 publishers in 40 languages. So while Scopus is a product of Elsevier, when we're talking about data from Scopus, we don't mean just like journal articles from Elsevier. It's much bigger than that. And you may check this Scopus content coverage guide for more information. So we started with 2 million publications from more than 600,000 researchers who have ties to Russia. So these are all the authorship records of people who have at some point in their career published with an affiliation address from Russia in the period 1996 to 2020. And then we focused on authorship records of individuals who have published with affiliation addresses from Russia, as well as affiliation addresses from some other countries. And that's how we got data on more than 500,000 publications from 30,000 internationally mobile researchers. So for our analysis, we mainly focus on these 30,000 researchers, but for some of the migration measurements, we also need to use all of the data for estimating the total number of researchers. So one of the challenges in this work was dealing with missing values. So affiliation addresses in Scopus are not standard. So for example, for University of Auckland, there were like, I'm just giving this example because I'm more familiar with the case of New Zealand universities. So for New Zealand, University of Auckland in New Zealand, I remember that there were something around 80,000, something around 80 variations of the name. Some people use the University of Auckland, some people use University of Auckland, some people use Auckland University, some would just use the name of the department with a street address, without a street address. And Scopus has pretty good reasons not to standardize this because they want to report exactly what appears in the publication due to copyright issues. So these affiliation addresses are not standard, and in many cases, so particularly we had 9,701 authors who had records where some records where the country was missing. And what we did for dealing with missing records was that we developed a neural network that takes an affiliation address as an input and predicts with a high accuracy the country associated with that affiliation address. So as for the majority of the data, the country variable was available. We trained the neural network on those records. And then we use the neural network to predict the missing countries for the remainder of the data. And we also tagged some of these missing records manually and tested the accuracy of the neural network, which turned out to be pretty good. So I don't remember the number from the top of my head, but it was something around 98% or more. So this is one of the main computational challenges, and you may check out this other paper that explains this neural network in more detail. Another challenge was about the Scopus author ID. So Scopus author identification system is not perfect, but it's actually pretty good compared to other sources of bibliometric data. So Scopus has this system that is meant to give a unique author identification number to each person. For this Scopus author ID, sorry, my phone is ringing. Let me just.
Samin, also there's one question in the chat.
Oh yes, maybe we can answer it. Please. I mean, I don't see the chat. If you can read it out.
From Maxim, he's asking like, how you received 2 million publications for Russian Scopus?
Scopus, because
yes.
I received only 1,300,000 document results for Scopus for affiliation country Russia. How you received 2 million documents?
Oh. So these are not just the records where the affiliation is certainly Russia. First, we query all the author IDs of all the individuals who have at some point have a publication with Russia. And then we use those records and query the data again for all publications matching these author IDs. So if a researcher has 2 publications with Russia, 20 with US, we get all 22 of them, you know? So maybe that's the difference.
Yeah,
so we have a kind of a more, slightly more complicated query. But you can imagine it as querying the system 2 times. First, getting all the author IDs of everyone who has at some point published with a Russian affiliation address. Then when you have those author IDs, request all the records matching those IDs.
Oh, so you received all publications of authors who have at least one publication affiliated with Russia.
Exactly. Yeah.
Okay.
And in the range 1996 to 2020, if you get that from Scopus, it would be something around 2 million.
Yes, so thank you.
2 million publications. In terms of authorship records, it would be much more. I mean, again, I don't remember from the top of my head, but maybe it was something around, I guess, 17 million, if I'm not mistaken.
Okay. Thank you.
All right. So yeah, this Scopus author identification system is not perfect, but it's actually pretty good. So they have like 2 measures for the reliability or accuracy of this system, because there are 2 things that can go wrong. There could be multiple individuals with possibly similar or the same name being given the same author ID. That's one challenge. And the other challenge is one individual having more than one author ID. Essentially, one individual having 2 author profiles, meaning that some of their publications appear in profile number 1, some of them in profile number 2. So they use these 2 measures, precision and completeness, and according to the communications we had with colleagues at Elsevier who are in charge of the author profiles and author identification system, as of August 2020, their precision is over 98%, meaning that over 98% of author profiles in Scopus only have records from one individual. And completeness is over 90%, which means for over 90% of author profiles in Scopus, the profile contains all records of that individual. So these are 2 complementary measurements. And there's a study that we have cited in the article that investigates whether this Scopus author ID is reliable for analyzing migration researchers, and they argue that it is indeed reliable. But as we were interested in migration, and migration could be could be quite sensitive to these problems, to individuals having the same ID or one individual whose publications are grouped into 2 different or multiple profiles, we decided to take the most conservative approach and do some author name disambiguation ourselves. So what we did was we started with looking at the outliers in the data. So we consider a record as a suspicious record if that author ID is associated with an usually high number of countries or an unusually high number of publications. So we had some thresholds that were kind of arbitrary, but based on these thresholds, we would say that, all right, this publication, this author ID is associated with so many publications, maybe like 400 publications, which means that over the period 1996 to 2020, if this is one person, they must have published on average more than 1 paper every month for 25 years for this to become 400. And that would be suspicious. I mean, in some cases, we see that it is actually correct. There is nothing wrong with that author ID. It's just some person who is super productive, but it's just some way of thinking about these outliers, or people who were associated with, who had affiliations from more than, I think the threshold was 6 countries. People who had like publications with affiliations overall in all their records from more than 6 countries. That looks a bit suspicious. It could be perfectly fine, but it could also be 6 different people, each in one country without any mobility, who happen to get the same author ID from Scopus somehow. And then what we did was we applied our own author disambiguation algorithm that is explained in this article. And this author disambiguation algorithm is very conservative. So we start with the idea that every 2 records are from distinct individuals. Despite having the same author ID, having the same first name, having the same last name, we initially start with the idea that every 2 records are from distinct people. And then we only cluster them together if there is some evidence of similarity. So for example, we look at the co-authors on those 2 different publications. If the co-authors have the same name, then it would be some evidence of similarity. We look at common references. Are those publications citing some of the same references? We look at the funding information. Do they have the same grant number, for example? And based on a range of these similarity measurements, we do these like pairwise comparisons between every 2 records, and we issue new and revised author IDs to these like outlier records. So that's how we deal with improving the quality of Scopus author IDs. All right, and then when these like quality checks and data pre-processing are done, we can start detecting international migration movements. So first we produce a new variable for each researcher, which is the mode country for each year. And here is an example. So let's think that the data looks like this. So the author ID of all these 3 rows is the same. And at this stage, we work with the assumption that if author ID is the same, this is the same individual. So this is one individual with 3 publications, because as you can see, there are 3 DOIs. There are some subject classifications associated to these records. So ASJC refers to All Science Journal Classification, which is a standard for journals and conference proceedings. And then country, this is the mode country. So the mode country for this person is 20, in the year 2012 is Russia, and the mode country in 2013 is Russia and US. And the mode country in 2015 is US. So what happens in terms of migration is that we go over these records one by one. When we get to the year 2012, we see that this person is in Russia based on the mode country. And then in the next year, there are multiple modes. There's Russia and US, and our analysis is based on the idea that a migration happens only if the previous mode country totally disappears. So while the mode country has changed between 2012 and 2013, we do not consider this as migration yet. Then we move on to the next record, and the mode country becomes US. Russia is not there in an array or anything, and that's where we consider that a migration has happened. And then we take the midpoint between 2013 and 2015 as the year that we think migration might have happened. This is like the best we can do with these numbers. Of course, there could be a lot of other possibilities, but that's how we're dealing with these data. There are some other methods in the literature. For example, there's the dichotomy of considering like travelers and migrants. And based on that idea, maybe like in the year 2013, you call this person a traveler, and then in 2015, you call this person a migrant. And this is just another alternative, but I'm more comfortable with the idea of only looking at migration. and having a conservative definition for migration. Is there a question? In the chat?
Well, looks good so far. Thanks.
Okay. So, yeah. And when we,
there is
yes.
there is one question in the chat by Elena.
Oh yeah, actually, yes, please.
I don't know if the person wants to ask a question.
Okay.
Can you say it?
All right, so I will just read the question out loud. Do you consider out-migration from Russia or in-migration to Russia and repeated migration from to Russia as well? So yeah, there could be, yes, definitely. This is actually quite important that we consider all movements. So some person may start in Russia, go to US, then go to Germany, then come back to Russia. So it could be more than one event for one person, if that's the question. And we get to all these details in the next slides. I hope I've answered the question. Okay. So when we plot all these movements that we detected by going through all these records, we get something like this. So the node on the top right is Russia, and the colors on the edges, which represent the movements, are based on the source country. So here, all the edges, all these lines that you see in red are representing movements of people from Russia to other countries. And all the edges in colors other than red represent movements from other countries to Russia. And the network would look like this. So here, each node is a country, as I mentioned earlier, and the thickness of the edges represent the flows in that direction. So if you take a look at these, the thickness of the edges, you would see that pretty much for all countries, the flows from Russia to those countries is more than the flow from other countries, those other countries to Russia. So, here, in the countries that are highlighted with different colors, the exception is Ukraine, for which the flow from Ukraine to Russia is more than the flow from Russia to Ukraine. And we can disaggregate this by different fields. So we have essentially 4 major fields: physical sciences, which includes basic sciences and engineering, for example, life sciences like biology, health sciences like medicine, and social sciences. And what we do is by looking at the frequencies of those subjects of the publication venues, we tag each person as one of these 4 categories, and those people who have like publications from different disciplines end up in a 5th category that we call multidisciplinary. And you can get more details from the article. And here you can see that the majority of these flows is in physical sciences, then life sciences, then health sciences, and social sciences having the least movements, the least international movements. Of course, there is a caveat here because we're measuring migration through the lens of publications, and there could be different cultures of publishing across these disciplines. So perhaps people who are in physical sciences, including physics, maybe on average they publish more papers per year compared to people in social sciences. Maybe you can think of a physicist and a historian. I assume that on average physicists publish more per year compared to historians, for example. So this is definitely a challenge, but if we do not I mean, as we have not control for these possible differences across disciplines, we cannot really say if these differences that we see on this plot are really meaningful. But the idea here is that these bibliometric data, as they are at the population level, they allow us to disaggregate further and further and look at these patterns by different categories. And that's pretty much what the main idea of this paper. All right, so the next thing we look at is net migration rate. So as many of you know, net migration rate is the fraction, is the number of people coming to a region minus the number of people moving out of a region over the population of that region at the start of the period. So, and when a net migration rate is positive, it means that the people coming to a region outnumber people moving out of that region. And in terms of migration of researchers, of course, a net migration rate is a positive thing for the science system of that country. So as you can see, this plot shows that over time, net migration rate has increased. So back in late 90s and early 2000, it was negative. And then it decreased in absolute term, and then in more recent years you can see that it has been even positive for some years. Again, there is another caveat. I need to remind you that we're talking about migration based on those definitions that I mentioned earlier, migration of published researchers. So if someone, let's say if an undergrad student or a graduate student who doesn't have a publication yet is in Russia, studies in Russia for undergrad, and then goes to US and have their first publication in US, that person would have US as the country of academic origin. And this is not meant to be country of birth or country of citizenship or country of nationality, but country of academic origin. We think of it as the country that must have invested in the academic development of that person leading to their first publication. So you need to consider this academic sense whenever you look at these plots. But overall, this plot shows that in terms of net migration rate, the situation seems to have improved for Russia over time. And then we can also disaggregate these. So, I mean, on this plot, if, for example, for the year 1998, the net migration rate is minus 2.4. So this means that for 1,000 researchers in Russia at the start of the year 1998, the movements of people from Russia to other countries and from other countries to Russia have been such that as if in total, 2.4 people have moved out of Russia. And this 2.4 is essentially the difference between in-migration rate and out-migration rate. So in the year 1998, you can see that the out-migration rate is 8.1, in-migration rate is 5.7. So 5.7 minus 8.1 would be minus 2.4. And here you can see how these rates could be disaggregated by disciplines. Again, you see that the majority is from physical sciences, and then we have life sciences, the multidisciplinary category and health category are kind of in the third position, and then social sciences, the last position. So another thing we do is to use these 4 types of migrants. So we have this classification for migrants, which is based on the country of academic origin and country of academic destination. So for people who start off in Russia and they are migrants, so they go somewhere else and they come back to Russia, so their country of academic origin and country of academic destination is Russia, we call them return migrants. People who start off in Russia and go to another country and as of the end of the period of analysis have not returned, we call them immigrants. People who start off in another country and then come to Russia, we call them immigrants. And people who start off in another country, come to Russia for some time, and then move to another country, we call them transients. Again, you may imagine that some of these people who we call immigrants could very well be people of Russian origin or Russian nationality who moved to other countries before their first publication and then come back to Russia, right? So if that's what might be on your mind, I must tell you that later on we see that actually whether we call these people return migrants or immigrants does not make a difference in our analysis. All right, so here you can see the differences in the performance of these researchers based on their citations. So we had the academic age of each individual based on the number of years since first publication. We also get all the citations of these individuals in total and then divided by academic age to get the average annual citation for each person, and then look at the differences across these categories, across these 10 groups that you see in the table. And what we can see is that, well, I mean, the standard deviations are pretty high, as you can see, so the differences are not statistically significant, but just in terms of average of annual citations of these researchers, we see that pretty much in all disciplines, immigrants, on average, just the average, have higher citations per year than immigrants. So this is just something that we need to consider, that it seems like people who leave Russia, go to other countries, somehow they end up with more citations on average compared to people who come to Russia. Of course, we do not have any like explanations, so these are just some descriptive analysis of what the data shows. And I would be glad if people who are interested in this work take it from here and look at the reasons why patterns are the way we see in here. All right, so the next thing I'm going to discuss, I think this part is quite delicate. I hope that I can explain it properly. So let's go back to the table we had with 3 publications. So what can we do with these subjects? So these subjects are essentially the disciplines or the subfields. So we have 20-something disciplines based on ASJC subjects, and we want to normalize the contributions of each person in each field. So this is a person who has contributed to mathematics, to energy, and to chemistry, right? So this is how we think about it. So as this person has 5 instances of subjects in total, and just one of them is energy, we simply consider normalized contribution of this researcher in the discipline of energy to be 1/5, right? Simply by looking at the frequency of how many times a subject is repeated across all publications of that person and dividing by the total. And for mathematics, we see mathematics 2 times in the table over 5. So normalized contribution of this person whose ID is X in the field of mathematics is 2/5. Now that we have these normalized contributions, we can add up all the numbers for a given discipline, and that's how we get a normalized population of migrants in discipline D. So by adding up normalized contribution, we get P of D, or population of discipline D. Any questions so far?
No, very good, except that we are running a little bit behind schedule.
Oh, all right.
So
okay, I will
just a gentle reminder.
Sure.
Okay, thanks
and
very
then
much.
we can also do this by different types of migrants. So we can use the same summation for immigrants, for transients, for immigrants, and for return migrants. And the idea here is that immigrants and transients they have a direct relationship with brain drain. So we consider that if a country has more immigrants and more transients, we assume that country must have higher brain drain. And countries that have more immigrants and more return migrants, their brain drain is lower. That's how we can add up these numbers for immigrants and transients with a positive coefficient, for immigrants and return migrants with a negative coefficient. And that's how we get our field-based net brain drain, which is the central part of our analysis, this fraction. And the idea is that when this FNBD for discipline D is positive, there is net brain drain in discipline D. This is considering all the possible movements, all the contributions of researchers moving out, moving in, moving out, and then coming back and everything. And then based on this field-based net brain drain, this is the image that we see. We can see that pretty much for all disciplines, all these movements have resulted in total on a loss for Russia. And the loss has been more substantial in neuroscience, decision sciences, dentistry, biochemistry, genetics, and molecular biology, and mathematics, as you can see on the top of this plot. And you may get more information from the article. So in the end, I would like to thank my great supervisee, Alexander Sobotin, and also Tom Tyler and Emilio Zaghini at the MPIDR for their support. This study was supported through this grant, and we got the data from the project Competence and Home Bibliometry, and we thank their funder, the Federal Ministry of Education and Research, and thank you for your time. You can access all these publications on archive. I'm happy to take your questions. Thank you very much.
Thanks very much, Samin. That's extremely interesting and informative. I'm sure there'll be lots of questions. And by the way, the attendance of this seminar is probably twice our average, so congratulations. Your topic attracts a great deal of attention from the colleagues. All right, please, questions, comments? Is there any? If I may, did you ever try to form a panel that shows how this brain drain evolves over time, and observations of the panel could be disciplines or something else, and try to relate flows and ebbs and flows to policies, changes, whatnot, economic situation?
Yeah, that would be certainly the next step. We want to look at all these movements based on their temporal structure over time. So here with the brain drain, what we did was just compressing everything to just one measure. So the temporal dimension was lost, but we can possibly restructure this as panel data and analyze it through time. But one problem is that when we just disaggregate it further and further, sometimes we really end up with tiny numbers. When we say neuroscience and movements out of Russia, maybe in a given year, I mean, the way we're measuring it, maybe we just end up with 5 people, so the variations are pretty high. But yeah, I'm sure that there could be ways of dealing with this data and doing sort of time series or taking the temporal aspect of the data into consideration.
All right. There is a question in the chat column, so please have a look.
So I will first just read the question out loud.
Please. Right.
Is it possible to understand the differences in citation publications activity between out migrants and stayers? Yeah, of course it is possible. We just didn't look into it. But yeah, this is a great idea. It's rather straightforward doing this because we have the data for all these people. The majority of them are stayers. So we had 600,000 people, and then just 30,000 of them were mobile. So the large majority of them are indeed stayers. So yeah, definitely we could look into these differences. But there was, I mean, we have not, this is not something that we have done, but there was a study showing that researchers who are internationally mobile, on average, they're performing better in terms of citations. So this is not really that surprising, because I guess there could be interplay in both directions. Maybe someone who is performing better, I mean, citation is just something that we have. Of course, it's a terrible measurement for performance, but someone who has like more citations, I assume, could have more opportunities for international mobility, and perhaps also international mobility opens up new connections and new more exposure to the work, and perhaps drives citations. And that's just my speculation, of course.
Very good, thanks. Please, further questions?
Next step in comparing stayers and out migrants would be cost-benefit analysis to evaluate losses, benefits in economic growth. Is it related question? What is your opinion? Yet it is certainly a highly relevant question. Well, I mean, we have not looked into anything like that, but I assume if in the future people who are interested on this topic could perhaps combine data about data like economic data and data on migration, I assume that there could be some really interesting analysis about the impact, the economic impact of these movements. But yeah, I assume that that these losses or these gains could be somewhat translated into economic opportunities and losses. And that's just my opinion. Of course, I have not looked into this, but yeah, with combining different data sets, this would be very interesting. So for this study, it's not formally accepted and published yet. It is available as a preprint on arXiv, and that's why we have not released the data yet. There's also some legal challenges. Of course, we are not allowed to release any raw data, but the data that we produce, the migration data, we plan to make some parts of it publicly available when the publication comes out. So also for our study of Mexico, we had like data on movements between these different states, which we have now made publicly available. So maybe, hopefully, if this work gets accepted and published in 6 months, in 1 year from now, there will be some data set accompanying the article for people who are interested.
Excellent. Please. While people are still thinking about their questions, if I may, another one for myself. It's not directly related to what you present, but just a general question. How do you think academic mobility has been affected by the pandemic? The answer is not obvious. On the one hand, people cannot travel, but on the other hand, my casual observations suggest that in fact people migrate online much more actively than before. So I wouldn't be surprised if there is an increase in papers with multiple affiliations during this time, because it's so easy to connect. So do you have anything to say on that topic?
I totally agree with you that that this COVID, of course, has changed many dimensions of life, and I'm pretty sure that it must have had some impact on scientific developments and collaborations and production of new knowledge and publications. Yeah, so I mean, in this work, we were more interested in migration, geographic migration, but there are other studies on science of science that are mostly about the data, and they look at collaborations and migration at the same time. So by looking at possible combinations of changes that can happen to affiliation addresses, they look at collaboration networks, how people use multiple affiliations, Yeah, how affiliations from different institutions appear together in one publication, and that's how they develop these collaboration networks. And yeah, I guess in some years from now, if we survive, it would be interesting to look at these, look at the data that would be that were produced in 2020, and look at possible changes and discontinuities. I assume that there would be some interesting trends at least.
Exactly. Thanks very much. Maxim Kotsimir has a question. Maxim, please.
Yes. So what the question asked, what was the reason for selecting? I'm answering another question.
There's a question that Maxim wants, I guess, to ask in person. Maxim, can you get your question?
Please.
Can you hear us?
Very interesting presentation, and my question is about how you show that you detected migration when one single author is no more affiliated with Russia but affiliated with some other country. Yes, but in many cases, for example, researchers from Russia migrated to, for example, France, but for several years this author puts affiliation formally with Russian university or organization, institute. Do you count such a situation as affiliation when person writes to affiliation Russia and France, Russia and France, Russia and France for several years?
Yes, definitely. So one challenge is the lag in terms of it takes time when someone actually does the geographic migration and goes to a new place. It takes time to conduct new research and publish them, and then we see those publications. So there's a lag between the actual time of mobility and the mobility that is manifested in publications. That's one challenge. Another challenge is the multiple affiliations. So regarding multiple affiliations, what we're doing is we're taking the mode country. So if someone moves, I mean, of course, like we don't know when people move, we just see their data, right? So if for an individual, the affiliation addresses across, let's say, 5 consecutive years, sorry, if it looks like this, if it's like Russia for year 1, then Russia and France, then Russia and France, then France. In this situation, we consider migration when Russia totally disappeared from the list. That would be year 4. And then for inferring the year of the movement, there are 2 things we can do. We can take the midpoint between year 1 and year 4, just take the average, maybe round it down, given that there is a lag. Or we can take the midpoint between year 3 and year 4. And I mean, of course, there are some other like better modeling, better statistical modeling of seeing what is the actual lag for different disciplines, and then maybe correcting for that. But our analysis was more about like cleaning the data, you know. So this kind of work is very is at its infancy, I think. So we're still like challenged by the author name disambiguation and data quality issues. That's why our analysis is very primitive. But yeah, so that's how we deal with multiple affiliations. And then for the lag, what we're doing is mainly taking the midpoint, and that would be how we think about the move year. But of course, better analysis could be done in that respect.
And
all right. Okay.
Those who changed affiliation multiple times. So first Russia, France, again Russia, and again, for example, Brazil, and again Russia. This was created as transient researchers. For what?
Yeah. So yeah, if these are the mode countries, you know, when we take the mode, actually, this like kind of this changes would kind of would be less. But let's say that the mode country is Russia, then it's France. Then we consider one path or one migration event from Russia to France. And then the next year, the mode country becomes Brazil. Then we consider one movement from France to Brazil. So yeah, there could be multiple events for one person. But in terms of those 4 categories, if this person goes from Russia to France and then from France to Brazil, for us, this person is just an immigrant. Yeah. Meaning that the part about moving from France to Brazil through the perspective of the Russian science system doesn't really matter. That person could have stayed in France and nothing would change in our analysis through the perspective of impact on Russian science system.
So you...
Okay. All right, well, if you please, we have several more questions. Denise, and it's in the chat column.
So Dennis asks, what was the reason for selecting 1996 as the start of the analysis period? So in the year, from the year 1996, the Scopus data become rather stable. The affiliation addresses become more reliable. And I think from that year, the inclusion of the data, the coverage of Scopus also becomes, kind of changes compared to the year before. That's why we take 1996. But yeah, I guess you need to check information about Scopus coverage for more information. But that was a choice that we made regarding data quality. Of course, it would be great if we can go to 80s or 70s, and so that we could, like in the context of Russia, we could have the time of collapse of the Soviet Union in the analysis period. But with Scopus data, 1996 is a pretty early start year where the data kind of makes some sense. Earlier than that, there would be big data quality problems. Another question from Natalia. I have 2 questions. Do you analyze the share of returned migrants by year or at all? Share of returned migrants, so we kind of, we quantified some sort of number of returned migrants by discipline and in total. And we did not do that by year, because the definition of returned migrant kind of has the temporal dimension built into it. So it takes time for someone to move out of Russia, spend some time and come back. So we don't have such a thing as in our analysis, we didn't have migrant types by years. We didn't have that. So it was like someone, like throughout the 25 years, we see how people move, go out, come back. And then in year 2020, each person has one of those 4 labels, either each migrant, either immigrant, emigrant, returned migrant, transient. The second question, do you compare situation in Russia with other countries? So not in this study, but in the first project I briefly mentioned, what we're doing is comparing countries. But that's mainly about highly mobile researchers. So it's a very specific subpopulation, but there is some comparison of different countries. For example, we see that it was based on the idea of super movers. So people who have been in 3 countries at least. For example, of course, like pretty much any science of science work, we see US and China dominating every comparison. But if we do some sort of like per capita measurements, for example, we saw that countries that had the highest number of super movers per capita were Switzerland and Singapore. But yeah, in that paper, you may find some comparisons across countries. Any other questions?
Please, any further questions?
I have a very small technical question. on the what you call these suspicious observations. Do you have a look on, I don't know, for example, if someone has a publication in economics and then in neurosciences, like it might seem suspicious. I don't know if you deal with this somehow or not.
Yeah, that's I think another like inclusion criterion for calling something suspicious, and it's not a bad idea. Of course, there are like people who go across who change subjects. I myself, I was in engineering, then I kind of moved to more like mathematics, then computer science. Maybe these are not that far away, and now I'm in the social sciences. But yeah, I mean, my impression was that having many publications, like some of these records we see that are associated with like 1,000 or 1,500 publications. These are pretty suspicious. And some people we see that they are affiliated with like more than 6 countries. So through these two criteria, some of them turn out to be totally normal. I mean, like in terms of author disambiguation, but we can actually catch many errors of the Scopus author identification system. So it's just mainly about that, like 2% of lack of precision, and that something around 9% lack of completeness that we are concerned with. And what we're trying to do is to kind of like target a part of the data where there's more error, you know. But yeah, your idea is relevant. Certainly, we could have different definitions of what is suspicious, but we just went with those two basic definitions.
Okay.
Of course, and another approach is to do a disambiguation of the whole thing, which is more challenging. So we just decided to trust the existing author identification system and further improve it. That was our approach. Another question, if the author ID had a long period without publication, like 10 years, isn't it the reason to conduct author disambiguation? Yes, that's certainly a good idea. But I think this is something that is already in Scopus system for splitting one author profiles into 2. So actually that is more about precision as opposed to completeness. And so Scopus is doing a pretty good job in terms of precision, meaning that records which would look like the one mentioned in the question, like a profile that has like a 10-year of inactivity in between, I think in most cases they would be already split. I mean, there wouldn't be that many records, you know, because Scopus is doing pretty good in terms of precision.
Okay, please, anyone else? Samin, can you tell us how common is it that people whose academic birthplace is in Russia and they move somewhere else, they preserve their affiliations with the Russian schools, with the Russian institutions? Because I think it's a common part when people move out, but they continue to be listed as faculty members. Their publications count. So is it something that you see in your data consistently?
Well, we have not looked into this because we just take those that like mode country, and then we lose every other information about every other piece of information about how these affiliations are changing. But yeah, like with the Scopus data, I think that value could be, that number could be quantified.
Because that might
but we didn't do it.
Yeah, that might be an important argument for policy measures towards academic mobility in Russia. It's not a pure brain drain. Someone moved somewhere else, but she continues to be affiliated with her home university and contributes to local development. I think that might be useful and worthwhile to look at if we have a chance.
Certainly. I mean, like our perspective was more about using this data to find migration patterns and analyze migration trends. So we were not, I think our approach was kind of different. That's why we didn't care about losing that information that is already in the data. But yeah, with that data, with a policy perspective, of course, it would be relevant to look at the number of people who move or who get a new affiliation, but also keep their previous affiliation for some time.
All right, thanks. Okay, one last chance to ask Samin about migration, everything you wanted to know but were afraid to ask. The time is now. Okay, well, I think you probably answered all the questions that people might have. So I have nothing else but to thank you very much once again. Samin, it's been extremely informative and thought-provoking. Hopefully
Thanks a lot. Thanks a lot for the opportunity and for your time joining this session. I'm really glad to see that this is interesting. And yeah, I hope that we will be able to publish this soon and hopefully make some data related data available for future work. So thanks a lot.
We are your subsample, so it might have some value for you as well. Okay, Bernarda, conventionally, please tell us what's coming up next.
Well, so next week is we have Andrei Tkachenko, who is actually here with us today. And he's going to present the competitive effect of vertical integration in auctions. So, well, same place, same time. And well, thanks, Samin, for your interesting presentation. And well, if you want to see more information, it's just in the chat, the link where you can see all the information about next week's seminar. So, well, thanks everyone for attending, and well, hope to see you next week.
Thanks.
Thanks again. Have a nice day. Have a nice evening, everyone.
And be safe. Bye-bye.